Hey everybody, welcome to our database management term project. The title of our project is Champions on the World's Biggest Stage, 120 Years of Olympic History. Compared to traditional analysis on a sport like basketball or soccer, the Olympics can provide new contributions into the historical evolution of athlete physiques and performance over time, and how regions and national origin impacts athletic performance and categories. We didn't want to do basic sports statistics queries, and we felt the Olympics allowed us to make more unique queries because it ties in national pride and is truly a one-of-a-kind event. Some analytical queries included discovering how athletes' physiques evolve over time, and also seeing if national origin had an effect on physiques. Changes in gender segregation and female participation in the games over the time, which athletes were the most dominant, that means competed for the longest stretches of time, and finding out which countries dominated, declined in success, and had rivalries over the games. When it comes to the technical depth and sophistication of our app, it was relatively complex. We use Flask as a backend and as a web framework for our application. This is because Flask makes things easy to route and to create different pages for our queries, and we also needed it to create individual HTML pages in CSS styling templates and static styling templates for each page. This allowed us to load our formatted data into the HTML and CSS template. In terms of our queries, they were very complex. We used advanced subqueries and more advanced SQL techniques, such as the usage of substrings to check date ranges, complex joins, and the rounding and casting of SQL data. We used plenty of aggregate functions throughout the course of this project. And the queries were not complex for no reason. Each one had a purpose. We wanted to show how data ranging across different time periods of the Olympics, in order to show changes over time, and especially we are proud of queries 2 and 4. So anyways, let's get to demoing our application. In order to start with our application, we must first create the database file. And we can do this by running python database.py. This will read from our CSV files and store the new database tables created in Olympics_database.db. This file is what our application will pull from in order to produce the queries. So, after that is done, we must secondly, enter our virtual environment. And this is done by typing source and then supplying the path to the script that activates our virtual environment. And that would be vim scripts activate. And after that, we can see we are now in our virtual environment because of this little tag right here. So now we can activate the server and host our application. And this is done by running the entry point, which you can just type python-m flask run. And after this is done, we can see our application is up and running. And then we can control click on this. And now our application is being displayed. So I'm just going to run through the front end quality and the UI aspects as I go. So give me 1 second. So we, like I said, decided to use Flask for our web framework because it's a lightweight framework that seemed to best fit our intentions with this project, and it allowed us to implement routing and to go to and from all the pages in our application. And it also allowed us to pass information from the back end to the front end with little to no hassle through the helper functions that Flask supplies. So let's go element by element. This up top here is the header for our homepage. The header was composed of 3 elements, with one of these elements being interactive. We'll go from left to right. The left is the assignment tag. We just wanted to denote that this is our term project for CSCI 4370 database management, and this tag is interactive. And upon clicking it from anywhere and any route and any endpoint in this application, it will return you to this homepage. And this was done by using an anchor element in HTML that links to the homepage. So I will demonstrate the use of this later once we get to viewing the query pages. Sorry. And then the second element is a neatly formatted Olympics logo, just to kind of represent what our project is about. And then the right-hand side of this header is a moving flag panel. And this was done by taking, is a image of several different nations' flags, and this was done in CSS by using the keyframes feature. I simply gave the image a linear movement on an infinite timescale and had it start from the left and move to the right side of the image. So that's our header. And after that, if you look at our background here, we had a hard time finding a suitable image online that would allow us to clearly display elements in the foreground, so we decided to make use of DALL-E, the AI art generator powered by OpenAI's GPT-4. The image it produced was stylistically sleek and not too noisy to serve its purpose, so we liked it and we went with it. Next, our title and description. We have our title displayed right here, and below it, we kind of have a synopsis, short synopsis of our project. Trends, stories, and triumphs from 120 years of Olympic history. These two elements are placed in an apparent manner, making sure that any viewer is not mistaken as to the purpose of our project. The next portion of our homepage is the query buttons. There are 4 query buttons, and each of these buttons lead to a separate page that displays the results of a particular query. These buttons were made by using the URL for helper function provided by Flask. This was done by constructing an anchor element within the button element in HTML and supplying the path to the page where we want to travel to once this button is clicked. And this was done for each separate button. Okay, so now let's move on to the query pages. Let's pick query 4 first. So as you can see, we click query 4, and now we are on a different route on the page of query 4. So for query 4, we wanted to take a look at the variation in size of athletes across 4 decades of the Olympics. So if you look at these 4 sections here, we have 1980 to 1990, 1990 to 2000, 2000 to 2010, and 2010 to 2016. And in each of these tables, we have the average height and average weight of all the athletes for each country across these 4 decades. And we thought this was a pretty interesting thing to look at, as there are several assumptions that could be interpolated from this data, such as improvement of diet, improvement of training strategies, and several other things. Okay, well, let's move on to our next query. So as you can see, I can click on this tag up here, and it will return us to our home page. And let's choose query 2. All right, so for query 2, we wanted to take a look at the amount of medals won by each country across 4 decades. So as you can see here, we use the same 4 decade ranges. And in the left column, we have the country, and in the right column, we have the corresponding number of medals won by that country in that decade. So this is a pretty interesting query. We can see either the rise in performance of a country throughout the years or the drop of a country's performance. So yeah, that's our second query. Now let's return to our homepage. So that is our project. We have a few other queries here, but we just wanted to show a couple of examples. Addressing our dataset quality, we just wanted to say it is a very good quality. The dataset we chose accurately stores information on, or has stored information on Olympic athletes and games over the past 120 years. And there are several different attributes that this dataset keeps track of. And it provided a solid foundation for us to produce 4 different queries and to analyze copious amounts of data across 120 years of the Olympics. Another thing I wanted to address was a little complication we had in the creation of this application. At first, our application ran slowly because of a bad backend order design, which involved creating database tables necessary for each query upon runtime. This was obviously a bad idea. So we did a little tinkering and we fixed the slow runtime and made it run smoothly by focusing on separation of concerns. We created the database independently, as you saw at the beginning of this demonstration, by first running database.py, and then in our main application, just accessing the database um, instead of updating it every time we wanted to make a query. And we access it through a cursor, um, and we could access it in different ways, however we needed to, depending on the query. So yeah, I just wanted to make a little note of that. Well, anyways, thank you for watching our video and letting us demonstrate our project for you. We hope you enjoyed, and yeah, thank you.